Tonight, as you look up at the star-filled sky above your head, you're gazing into what might be the universe's most terrifying secret. Those countless points of light scattered across the cosmic darkness aren't just distant suns burning in empty space. They could be home to civilizations far more advanced than ours, species that have mastered technologies we can barely imagine, societies that have existed for millions of years, longer than human civilization has even existed. So where are they? Where are the radio signals flooding our telescopes? Where are the massive engineering projects that should be reshaping entire solar systems? Where are the spacecraft visiting our neighborhood? The evidence of intelligence that should be everywhere we look? The silence is deafening, and according to one of the most chilling theories in modern science, that silence might be the only thing keeping our species alive. Welcome back to another journey into the deepest mysteries that keep scientists awake at night. Before we dive into what might be the most unsettling idea ever proposed about extraterrestrial life, I'd love to know where you're watching from tonight and what keeps you wondering about the possibility of life beyond Earth. And if you find yourself drawn to these cosmic mysteries that challenge our understanding of existence itself, I'd be incredibly grateful if you gave this video a like and perhaps subscribe to join our community of truth seekers exploring the universe's darkest secrets. Get ready, the story begins now. This is the story of the dark forest hypothesis, a theory so disturbing in its implications that it transforms the entire cosmos from a place of wonder and possibility into something far more sinister. By the time we finish this journey together, you'll understand why some of the world's most brilliant minds believe that every radio signal we broadcast into space, every message we send to the stars, every attempt we make to announce our presence to the galaxy might be signing humanity's death warrant. Picture this scene. It's a summer day at Los Alamos National Laboratory in New Mexico, and four of the world's most brilliant physicists are walking to lunch. They're discussing flying saucers, the recent wave of UFO sightings that have been capturing headlines across America. The conversation is light, almost playful, as these titans of science joke about the possibility of faster-than-light travel and alien visitations. Then, as they settle into their seats at the cafeteria, one of them falls silent. His mind has wandered from the casual banter to something far more profound. The numbers are swirling in his head. 200 billion stars in our galaxy alone. Billions of years of cosmic evolution. Countless opportunities for life to emerge, evolve, and spread across the cosmos. Suddenly, Enrico Fermi looks up at his colleagues and asks a question that will haunt humanity for decades to come. Where is everybody? Those four simple words contain within them one of the most profound mysteries our species has ever encountered. With the vast scale of the universe and the almost incomprehensible amount of time that has passed since the Big Bang, the emergence of intelligent life should be not just possible but inevitable, common even. We should be surrounded by evidence of alien civilizations. Our radio telescopes should be picking up their transmissions. Our spacecraft should be encountering their artifacts. The night sky should be alive with the artificial lights of countless technological societies. The very fact that we exist proves that intelligence can evolve in this universe, so why aren't we seeing it everywhere else? This became known as the Fermi Paradox, and for over 70 years, scientists have been wrestling with its implications. Every attempt to resolve it leads to more questions, more unsettling possibilities about the nature of life and intelligence in our cosmos. To understand just how puzzling our cosmic loneliness really is, we need to examine the mathematics that make alien life seem not just probable, but virtually certain. In 1961, astronomer Frank Drake developed an equation that attempted to quantify our expectations for finding extraterrestrial intelligence. The Drake equation multiplies together factors like the rate of star formation in our galaxy, the fraction of stars that have planets, the number of planets that could develop life, and the likelihood that life becomes intelligent and technologically capable. Our conservative estimates, the galaxy contains somewhere between 100 and 400 billion stars. A significant fraction of these stars have planets orbiting within their habitable zones where liquid water could exist on planetary surfaces. Recent discoveries by space telescopes like Kepler have revealed that potentially habitable worlds are incredibly common throughout the galaxy. When you plug reasonable values into the Drake equation, you arrive at estimates suggesting there should be at least dozens, and possibly thousands, of communicating civilizations within our cosmic neighborhood. Yet when we point our most sensitive radio telescopes toward the stars, we hear nothing but cosmic background noise. This absence of signals becomes even more puzzling when you consider how detectable our own civilization has become. For over a century, human technology has been inadvertently broadcasting our presence to the cosmos through television, radio, radar, and other electromagnetic communications. Our radio bubble now extends approximately 100 light-years from Earth, encompassing thousands of star systems that could potentially harbour advanced civilizations. Any alien society within this expanding sphere of influence would be receiving what amounts to a constant barrage of signals from our direction. They would know not just that intelligence exists on Earth, but could potentially decode our transmissions to learn about our technology, our culture, even our entertainment preferences. Yet despite this century-long advertisement of our existence, we've received no response. The search for extraterrestrial intelligence, or SETI, represents humanity's most systematic effort to detect signs of alien civilizations. Using increasingly sophisticated technology, SETI researchers have scanned millions of stars across vast ranges of frequencies, searching for the telltale signatures of artificial signals that would indicate the presence of technological intelligence. The most famous candidate's signal came on August 15, 1977, when volunteer Jerry Eman detected an extraordinarily strong signal using the Big Ear radio telescope in Ohio. The signal was so unusual and attention-grabbing that Eman circled it on the computer printout and wrote "Wow" in the margin, giving the detection its lasting nickname. The WOW signal had many characteristics that researchers look for in potential extraterrestrial communications. It was narrowband, indicating artificial rather than natural origin, and it appeared to come from the direction of the constellation Sagittarius. But the WOW signal lasted only 72 seconds and was never detected again, despite numerous follow-up observations. This pattern of intriguing but ultimately inconclusive detections has characterized SETI research for decades. Modern efforts like the Breakthrough Listen project, with $100 million in funding and access to the world's most powerful radio telescopes, represent the most comprehensive search for alien communications ever undertaken. Yet after scanning thousands of hours of observations across billions of frequency channels, researchers have found no convincing evidence of artificial signals from beyond Earth. Even recent detections that initially generated excitement, like the BLC. One signal discovered in 2020 during observations of Proxima Centauri, our nearest stellar neighbour, ultimately proved to be interference from human technology rather than genuine extraterrestrial communications. The signal had initially seemed promising because it appeared to originate from the direction of a star system known to harbour at least one potentially habitable planet, but extensive analysis revealed its terrestrial origin. This consistent failure to detect alien signals, despite the statistical expectation that they should exist, demands an explanation. Something must account for the profound disconnect between our theoretical predictions and observational reality. Over the decades, scientists have proposed numerous solutions to the Fermi Paradox. Perhaps life itself is far rarer than we assume, requiring such specific conditions that Earth represents a cosmic anomaly. This rare Earth hypothesis suggests that, while simple life might be common throughout the universe, the complex chain of evolutionary developments that led to intelligent, technologically capable species like humans might be extraordinarily unlikely. Alternatively, the barrier might lie not in the emergence of life, but in its survival. The Great Filter Theory, developed by economist Robin Hanson in the 1990s, proposes that there exists some extremely difficult evolutionary or developmental hurdle that prevents most life from reaching advanced technological capability. This filter could be located at any point in the progression from basic chemistry to spacefaring civilization. Perhaps the emergence of self-replicating molecules is incredibly rare, occurring on only a tiny fraction of potentially habitable worlds. Maybe the transition from single-cell to multicellular life represents an almost insurmountable obstacle, or intelligent species inevitably destroy themselves through warfare, environmental destruction, or technological catastrophes before achieving interstellar capability. Recent research has focused particular attention on what some call the technological singularity filter, the possibility that advanced civilizations typically eradicate themselves through the development of dangerous technologies like artificial intelligence, nanotechnology, or weapons of mass destruction. Humanity is already more than capable of destroying itself through global thermonuclear war, and we're rapidly approaching the development of artificial intelligence systems that could surpass human cognitive abilities entirely. If such technological self-destruction is virtually inevitable among developing civilizations, it would explain why the galaxy appears empty despite the abundance of potentially habitable worlds. Every species might follow the same tragic trajectory, emerging from their home planet, developing powerful technologies, and then succumbing to the dangers those technologies create before they can establish a lasting presence among the stars. But there's another explanation for our cosmic loneliness that's far more chilling than any we've discussed so far. What if intelligent civilizations aren't rare at all? What if the galaxy is actually teeming with advanced species, but they've all learned something about the nature of cosmic survival that we haven't yet discovered? What if the universe isn't empty, but filled with civilizations so terrified of each other that they've all chosen to remain completely silent and hidden, knowing that revealing their presence would invite immediate annihilation? This is where our story takes a turn toward the truly disturbing. In 2008, Chinese science fiction author Liu Cixin published a novel that would introduce the world to one of the most unsettling concepts ever proposed about the nature of interstellar civilization. The Dark Forest, the second book in Liu's acclaimed three-body problem trilogy, presented a vision of the cosmos so alien and threatening that it challenged every optimistic assumption about the possibility of peaceful contact with extraterrestrial intelligence. Liu's novel didn't just entertain readers with an imaginative story, it introduced a theoretical framework that scientists and philosophers have taken seriously as a potential solution to the Fermi Paradox. The dark forest hypothesis suggests that the universe operates according to principles so ruthless and unforgiving that survival requires adopting strategies that seem almost unthinkably paranoid from our current perspective. The hypothesis derives its name from a haunting metaphor that Liu uses to describe the cosmic environment. Imagine the universe as a vast, dark forest, where every civilization is like an armed hunter moving silently through the trees. Each hunter knows that others exist somewhere in the darkness, but cannot determine their intentions, capabilities, or exact locations. The forest is filled with potential threats, and the slightest sound might attract the attention of predators far more dangerous than oneself. In this cosmic forest, every civilization faces the same terrible dilemma. If you encounter another hunter, whether they appear to be an angel or a demon, a helpless child or a powerful warrior, a peaceful explorer or an aggressive conqueror, there's only one rational choice: eliminate them immediately before they have the chance to eliminate you. This isn't presented as malevolent behavior, but as the only logical survival strategy in an environment where the stakes are absolute, and the consequences of making the wrong decision about another civilization's intentions could mean the complete extinction of your own species. The theoretical foundation of the dark forest hypothesis rests on what Liu calls cosmic sociology, a field of study that attempts to understand how civilizations might interact across the vast scales of space and time. This framework begins with two fundamental axioms that seem almost trivially obvious but lead to profound conclusions when combined with other factors. The first axiom states that survival is the primary need of any civilization. This establishes that self-preservation isn't just important, but represents the ultimate driving force for any intelligent species. All other considerations are secondary to continued existence. The second axiom observes that civilizations continuously grow and expand, but the total matter in the universe remains constant. This creates the fundamental scarcity problem that drives cosmic competition. If civilizations naturally expand over time, but the universe contains only finite resources, then eventually all civilizations must compete for the same limited materials needed for survival and expansion. These basic axioms alone don't create the dark forest scenario, but when combined with two additional concepts, chains of suspicion and technological explosion, they create a logical framework that makes preemptive destruction appear to be the only rational choice for any civilization seeking to maximize its chances of long-term survival. The concept of chains of suspicion addresses a fundamental problem in interstellar relations: the impossibility of truly knowing another civilization's intentions across the vast distances and timescales involved in cosmic communication. Even if a civilization appears peaceful when first contacted, there's no way to guarantee they will remain peaceful, especially considering the factor of technological explosion. A chain of suspicion develops because civilization A cannot know if civilization B is hostile. Even if B appears benevolent, A cannot know if B thinks A is hostile. Furthermore, A cannot know if B thinks that A thinks B is hostile, creating an infinite regress of uncertainty that makes trust essentially impossible across interstellar distances. The technological explosion concept refers to the unpredictable and exponential rate at which civilizations can advance technologically. A civilization that appears primitive and harmless when first detected might undergo rapid technological development and become a significant threat by the time any communication or response is possible across interstellar distances. This means that even if another civilization seems completely harmless today, the time delays inherent in interstellar communication mean they could become vastly more advanced and potentially dangerous by the time any meaningful exchange of information occurs. What appears to be a peaceful agricultural society, when your first signals reach them, might have developed devastating weapons and aggressive expansion capabilities by the time their response reaches you decades or centuries later. These concepts, when combined with the basic axioms of cosmic sociology, create a situation where the only rational response to detecting another civilization is immediate preemptive destruction. Waiting to assess their true intentions or capabilities carries too much risk of your own annihilation, because they might be making the same calculations about you. From this perspective, the galaxy becomes a killing field, where the first civilization to be detected is the first to die. Advanced species that have survived long enough to spread across multiple star systems have done so by mastering the art of remaining completely invisible while simultaneously developing the capability to eliminate any potential threats before they can become dangerous. This transforms our understanding of what it means to search for extraterrestrial intelligence. Every radio telescope we point at the stars, Every message we broadcast into space, every attempt we make to announce our presence to the cosmos might be equivalent to lighting a signal fire in a forest full of hidden predators. We've been screaming our existence to the galaxy for nearly a century through our television and radio broadcasts, completely unaware that we might be advertising ourselves as targets to civilizations that view any form of contact as an existential threat requiring immediate and decisive response. The dark forest hypothesis suggests that the electromagnetic radiation surveys conducted by SETI programs would never find evidence of intelligent alien life. Not because such life doesn't exist, but because any civilization advanced enough to communicate across interstellar distances has learned that survival requires absolute silence. The galaxy might be filled with thousands or even millions of advanced civilizations, each one desperately trying to remain undetected while monitoring space for signs of emerging intelligence that might eventually pose a threat. When they detect the radio signature of a newly technological civilization like humanity, they launch some form of directed attack, perhaps self-replicating robotic probes, relativistic kinetic weapons, or other exotic technologies we can't even imagine, to eliminate the potential threat before it can develop defensive capabilities. Such an attack might take decades or centuries to reach its target, traveling at sublight speeds across the vast distances between stars. But predator civilizations can afford to wait because the alternative, allowing potential competitors to develop advanced technology, poses an unacceptable risk to their own species' survival. From this terrifying perspective, the fact that we continue to exist might mean one of several things. Either the dark forest hypothesis is incorrect, no advanced predator civilizations exist within our current radio horizon of about 100 light-years, or an attack launched against us decades ago is still traveling toward Earth and simply hasn't arrived yet. The implications are so disturbing that they force us to reconsider everything we thought we knew about the search for extraterrestrial intelligence and our place in the cosmic order. If the dark forest hypothesis is correct, then our species has spent the last century making one of the most catastrophic mistakes in human history, announcing our presence to a galaxy filled with hidden predators who view our very existence as a threat requiring elimination. But is this chilling vision of cosmic paranoia and preemptive destruction really the most likely explanation for our apparent solitude in the universe? As we'll discover, the dark forest hypothesis faces significant challenges from scientists and theorists who argue that its assumptions about alien behavior might be fundamentally flawed. But perhaps the most disturbing aspect of the dark forest hypothesis isn't what it says about alien civilizations, but what it reveals about the fundamental nature of intelligence itself when confronted with existential uncertainty. The theory suggests that rationality, when applied to cosmic-scale survival scenarios, inevitably leads to paranoia and preemptive violence. Consider the psychological profile that the dark forest model implies for any surviving galactic civilization. They would need to be simultaneously hyper-intelligent and utterly ruthless. Patient enough to wait millennia between actions, yet decisive enough to eliminate entire species based on nothing more than the possibility of future threat. They would possess technologies capable of destroying civilizations across interstellar distances, but use those same technologies primarily for hiding and surveillance. This creates what researchers call the observer paradox of the dark forest. If predator civilizations are monitoring the galaxy for emerging threats, they must necessarily reveal themselves through the act of observation. The energy signatures required for such comprehensive surveillance, the infrastructure needed to maintain galaxy-spanning detection networks, the coordination between multiple predator civilizations, all of these activities would themselves be detectable by sufficiently advanced technology. Yet we see no evidence of such monitoring systems, no anomalous energy signatures that might indicate massive surveillance operations, no coordination signals between hidden civilizations. No technological artifacts left behind by species conducting galactic reconnaissance. The very absence of evidence for the surveillance apparatus that the dark forest requires might itself be evidence against the hypothesis. Dr. Seth Shostak, senior astronomer at the SETI Institute, has pointed out another fundamental flaw in the dark forest logic. If everyone is hiding, he asks, who exactly are they hiding from? The hypothesis requires the simultaneous existence of ultra-cautious civilizations that remain perfectly concealed and ultra-aggressive civilizations capable of detecting and destroying those hidden societies. But if the aggressive civilizations are successful at eliminating threats, they would eventually eliminate all the cautious civilizations, leaving only the aggressors. And if the cautious civilizations are successful at hiding, there would be no aggressive civilizations left to hide from. This logical paradox becomes even more complex when we consider the diversity of evolutionary pathways that could produce intelligence. The dark forest hypothesis assumes that all civilizations, regardless of their evolutionary history, environmental pressures, or cultural development, would arrive at identical conclusions about cosmic survival strategy. This seems implausible given the vast range of conditions under which intelligence might emerge. On Earth alone, we see remarkable differences in human beings. Some respond to threats with violence, others diffuse conflicts before they escalate. Why would alien civilizations, evolved under completely different conditions on worlds with different pressures, all converge on the same paranoid, aggressive approach to interstellar relations? The non-exclusivity problem poses perhaps the strongest challenge to the dark forest model. If there are thousands or millions of civilizations in the galaxy, as optimistic interpretations of the Drake equation suggest, then even if 99% of them follow dark forest principles and remain hidden, the remaining 1% would still represent hundreds or thousands of civilizations that might behave differently. Some civilizations might be naturally curious and exploratory, driven by scientific rather than survival motivations. Others might be so technologically advanced that they don't fear potential threats from younger civilizations. Still others might have developed cooperative rather than competitive worldviews, perhaps through evolutionary pressures that favored collaboration over conflict. Some might even be post-biological, having transcended their original physical forms in ways that make traditional concepts of resource competition irrelevant. The existence of even a small percentage of non-conforming civilizations would be sufficient to make their presence known to the galaxy through radio transmissions, mega-scale engineering projects, or direct contact with other species. Yet we observe no evidence of such activity, which suggests that either the dark forest hypothesis is incorrect, or the number of civilizations in the galaxy is much smaller than optimistic estimates suggest. This brings us back to alternative explanations for the Fermi Paradox that don't require universal adoption of dark forest behavior. The Great Filter theory remains one of the most sobering possibilities, that there exists some extraordinarily difficult hurdle in the development from simple chemistry to spacefaring civilization that most life never overcomes. Recent research has identified several potential filter candidates that could explain our cosmic loneliness without invoking hidden predator civilizations. The emergence of self-replicating molecules from non-living chemistry might be vanishingly rare, occurring perhaps on only one world out of billions. The transition from prokaryotic to eukaryotic cells, which happened only once in Earth's history despite billions of years of evolution, might represent another nearly insurmountable barrier. Even more concerning is the possibility that the Great Filter lies ahead of us rather than behind us. Advanced civilizations might typically destroy themselves through technological mishaps long before they develop the capability for interstellar expansion. Nuclear warfare, environmental collapse, artificial intelligence, alignment failures, or encounters with exotic physics phenomena could serve as universal civilization-ending events. The technological singularity filter has gained particular attention among researchers studying existential risk. As civilizations develop increasingly powerful technologies, they might consistently reach a point where their creations exceed their ability to control them safely. Artificial general intelligence, nanotechnology, or other transformative technologies could represent evolutionary dead ends that no species successfully navigates. If this technological filter is universal, it would explain both the Fermi Paradox and provide a different interpretation of the silence from space. We might be surrounded not by hiding civilizations, but by the archaeological remains of species that, like us, developed radio technology and spaceflight, but then encountered insurmountable technological challenges that ended their expansion into the cosmos. Climate change offers a particularly relevant example of how technological capability can create existential risks. Every civilization that discovers fossil fuels faces the same fundamental challenge. The energy sources that enable rapid technological development also threaten long-term planetary habitability. The window between developing industry and developing sustainable energy might be so narrow that most civilizations fail to navigate it successfully. Similarly, the development of artificial intelligence might represent a universal filter that eliminates technological civilizations before they can establish interstellar presence. The timeline for AI development appears to be much shorter than the timeline for becoming a multiplanetary species, creating a race between transcendence and extinction that most civilizations might lose. Dr. Nick Bostrom's research on existential risk suggests that advanced civilizations face what he calls the vulnerable world hypothesis, the possibility that technological development naturally leads to capabilities that are difficult to control and potentially civilization-ending. If certain discoveries or inventions are inherently dangerous and impossible to uninvent, then every civilization that reaches sufficient technological sophistication might face an increasingly narrow path between stagnation and self-destruction. Yet another class of explanations focuses not on the rarity of intelligence or the dangers of technology, but on the possibility that advanced civilizations naturally lose interest in galactic expansion and communication. The transcension hypothesis suggests that sufficiently advanced civilizations turn inward rather than outward, focusing their energy on developing increasingly sophisticated internal experiences rather than expanding across physical space. As virtual reality, artificial intelligence, and other immersive technologies advance, civilizations might find that they can create experiences far more rewarding than exploring the physical universe. Why undertake the dangerous, expensive, and time-consuming process of interstellar colonization when you can create unlimited worlds of perfect experience within your own computational systems? This inward-turning tendency could explain the Great Silence without requiring either extinction or hiding. Advanced civilizations might simply become absorbed in their own technological paradises, losing interest in the external universe and ceasing all forms of outward communication or expansion. From our perspective as external observers, such civilizations would be effectively invisible, indistinguishable from extinction. The possibility becomes even more intriguing when we consider that such technologically transcendent civilizations might still exist in our cosmic neighborhood, pursuing goals and experiencing realities so far beyond our comprehension that we wouldn't recognize signs of their activity even if we encountered them directly. They might manipulate matter and energy in ways that appear natural to our limited understanding, or operate on timescales so different from biological experience that their activities are invisible to creatures like ourselves who exist within brief spans of decades rather than geological epochs. Some researchers have even speculated about the possibility of Kardashev recession, the idea that truly advanced civilizations become more, rather than less efficient in their energy use, developing technologies so sophisticated that their activities produce smaller rather than larger signatures detectable by less advanced species. Instead of building massive Dyson spheres around stars to harvest energy, they might develop quantum technologies that extract usable energy from vacuum fluctuations or other exotic sources that leave no detectable trace. This perspective transforms the absence of obvious alien megastructures from evidence of empty space into evidence of technology so advanced that it operates beyond our current ability to recognize artificial manipulation of the universe. The galaxy might be filled with civilizations whose engineering projects are so elegant and efficient that they're indistinguishable from natural processes to species like ourselves who are still learning to harness chemical and nuclear energy. But perhaps the most unsettling possibility is that we're asking the wrong questions entirely. The Fermi Paradox assumes that advanced civilizations would naturally expand across the galaxy, communicate with other species, and leave detectable evidence of their existence. But these assumptions are based on human psychology and human understanding of rational behavior. What if intelligence, when it reaches sufficient sophistication, naturally develops motivations and goals that are completely alien to our current understanding? What if the drive to explore, expand, and communicate that characterizes human civilization represents a relatively primitive stage of intellectual development that advanced species transcend entirely? The universe might be filled with forms of intelligence so advanced that their relationship to physical reality is fundamentally different from our own. They might exist primarily as information rather than matter, operate across multiple dimensions simultaneously, or have merged so completely with the quantum fabric of spacetime that distinguishing between their activities and natural physical processes becomes meaningless. From the perspective of such beings, younger civilizations like humanity might be as irrelevant as bacteria are to us, not threatening enough to eliminate, not interesting enough to contact, simply part of the background noise of a universe where true intelligence operates on scales and timelines that biological creatures cannot comprehend. This possibility is perhaps more disturbing than either the dark forest or great filter scenarios, because it suggests that our entire framework for understanding intelligence and civilization might be hopelessly limited. We might be like ants trying to understand human civilization, capable of recognizing only the most crude and obvious manifestations of intelligence while remaining completely oblivious to its more sophisticated expressions. The implications extend beyond mere scientific curiosity into fundamental questions about meaning and purpose. If intelligence naturally evolves beyond the need or desire for the kinds of activities we associate with advanced civilization, then our dreams of joining a galactic community or leaving a lasting mark on the cosmos might be based on profound misunderstandings about the nature of intellectual development itself. As we continue broadcasting our presence to the stars and searching desperately for signs of our cosmic neighbours, we might be engaged in an enterprise that advanced civilizations view with the same mixture of amusement and indifference that we feel when observing the complex social behaviours of insects. Our radio telescopes might be picking up their communications constantly, but in forms so sophisticated that we interpret them as natural background radiation rather than evidence of intelligence. The silence from space might not be empty at all, but filled with conversations we lack the wisdom to recognize, engineering projects we mistake for natural phenomena, and forms of consciousness so advanced that they operate beyond our current capacity for detection or comprehension. In this light, our cosmic loneliness becomes not evidence of our uniqueness or our doom, but testimony to the vast gulf that separates newly emerged intelligence from its mature forms. We might be living in a universe teeming with awareness and creativity, but awareness that has evolved so far beyond our current understanding that its presence remains invisible to our primitive instruments and concepts. The question then becomes not whether we are alone, but whether we can develop the wisdom and sophistication necessary to recognize the intelligence that might be all around us, operating according to principles and purposes that transcend our current ability to imagine. The greatest discovery in human history might not be finding aliens, but learning to perceive the universe as it truly is, rather than as our limited perspective suggests it should be. The practical implications of these competing theories become even more profound when we consider humanity's current situation in this cosmic puzzle. Right now, as we speak, our civilization stands at a crossroads that might determine not just our own fate, but our understanding of intelligence itself throughout the universe. For nearly a century, we've been inadvertently announcing our presence to any listening civilizations within 100 light-year radius of Earth. Every television broadcast, every radar pulse, every radio transmission has been leaking into space, creating an expanding bubble of electromagnetic evidence that screams intelligent life exists here to anyone with the technology to detect it. But we haven't just been passive broadcasters. We've actively tried to make contact. In 1974, scientists used the Arecibo radio telescope to beam a carefully crafted message toward the globular star cluster M13. This message, encoded in binary, contained information about our numbering system, the basic elements of chemistry, Earth's population, and even a crude representation of human anatomy. We literally drew a picture of ourselves and broadcast it into the cosmos, complete with our home address. The Pioneer and Voyager spacecraft, launched in the 1970s, carry golden records and metal plaques designed to communicate with any alien intelligence that might encounter these robotic ambassadors. These messages include sounds from Earth, images of human life, and mathematical constants that we assume any advanced civilization would recognize. We've essentially sent cosmic messages in bottles, hoping that someone out there might find them and understand that we exist. From the perspective of the dark forest hypothesis, these actions represent potentially the most catastrophic mistakes in human history. We've been lighting signal fires in what might be a forest full of armed predators, completely unaware that our attempts at friendly contact could be interpreted as threats requiring immediate elimination. The timing becomes particularly ominous when you consider the trajectory of human technological development. We've progressed from the first radio transmissions to nuclear weapons in less than 50 years. We've gone from primitive computers to artificial intelligence systems that can beat humans at complex games and solve problems we couldn't imagine just decades ago. Our rate of technological advancement is accelerating exponentially, and this acceleration itself might be what triggers a dark forest response from hidden civilizations. Think about it from an alien perspective. You're monitoring the galaxy for potential threats when you detect radio signals from a previously quiet solar system. At first, the signals are primitive, clearly from a species that has just discovered electromagnetic communication. But within decades, you're detecting more sophisticated transmissions, evidence of nuclear technology, and signs of rapid computational advancement. The species that was barely technological yesterday might develop interstellar capability tomorrow. This is where the concept of technological explosion becomes truly terrifying. Advanced civilizations monitoring our solar system might not be concerned about humanity as we exist today with our chemical rockets and primitive space technology, but they would be intensely concerned about humanity as we might exist in 50 or 100 years, with technologies we can't even imagine yet. The dark forest logic suggests that the optimal time to eliminate a potential threat is before that threat becomes capable of defending itself or retaliating. A civilization that waits to assess our true intentions might find themselves facing a species that has developed technologies capable of threatening their own survival. From a purely strategic standpoint, the rational choice would be to launch an attack now, while we're still confined to a single planet and lack the infrastructure to defend ourselves effectively. This creates what researchers call the preemption paradox of interstellar relations. The very act of trying to assess whether another civilization poses a threat gives that civilization time to become more threatening. The safer strategy is to assume hostility and act accordingly, which creates a self-fulfilling prophecy where the galaxy becomes hostile precisely because everyone assumes it is hostile. The psychological implications for human civilization are staggering. If the dark forest hypothesis is correct, then every day we continue to exist might be borrowed time. Every radio telescope we build, every space mission we launch, every scientific discovery we announce to the world might be the final piece of evidence that convinces a hidden predator civilization that we've become too dangerous to ignore. Some researchers have calculated the timeline between our first radio transmissions and the earliest possible arrival of a relativistic weapon launched in response. If a hostile civilization detected our signals from 50 light-years away and immediately launched an attack traveling at 10% of light speed, that weapon would arrive at Earth approximately 500 years after our first broadcasts. We're still well within the danger window for civilizations throughout our local cosmic neighborhood, but the dark forest scenario faces a crucial test in the coming decades as our own technology advances. If predator civilizations are monitoring emerging species for signs of dangerous development, then certain technological milestones might trigger automatic responses. The development of artificial general intelligence, the construction of self-replicating robotic systems, or the achievement of fusion power might serve as red lines that prompt immediate intervention. Alternatively, our continued survival past these technological thresholds might serve as evidence against the dark forest hypothesis. Every year that passes without a catastrophic attack from space provides additional data points, suggesting that either the galaxy is empty, predator civilizations don't exist within our detection horizon, or the fundamental assumptions of dark forest theory are flawed. The hypothesis also struggles to explain certain aspects of our current situation that seem inconsistent with a galaxy full of paranoid, hiding civilizations. If advanced species are desperately trying to remain undetected, they would presumably have developed technologies for identifying and eliminating any traces of their own activities. Yet our increasingly sophisticated astronomical instruments continue to discover phenomena that we can't easily explain through known natural processes. Fast radio bursts, mysterious stellar dimming patterns like those observed around Tabby's star, and anomalous acceleration in spacecraft like the Pioneer probes all represent potential signatures of advanced technology. While none of these phenomena have been definitively attributed to alien intelligence, their existence suggests that if advanced civilizations are out there, they're not being perfectly successful at hiding all evidence of their activities. The recent discovery of Oumuamua, the first confirmed interstellar object to visit our solar system, raised similar questions. This strange elongated object exhibited non-gravitational acceleration that some researchers suggested might indicate artificial origin, though most scientists now favour explanations involving outgassing from exotic ices. Still, the episode highlighted how difficult it would be for advanced civilizations to completely eliminate all traces of their presence across the vast scales of interstellar space. Furthermore, the dark forest model assumes that advanced civilizations would be capable of perfect surveillance and instant response across galactic distances. But the physics of information transmission suggests that even the most sophisticated technology cannot overcome the fundamental speed of light barrier for communication and coordination. A galaxy-spanning network of predator civilizations would face enormous challenges in maintaining real-time awareness of threats and coordinating responses across distances measured in tens of thousands of light-years. These practical limitations led some researchers to propose modified versions of the dark forest hypothesis that might be more consistent with physical constraints. Perhaps predator civilizations don't attempt to monitor the entire galaxy, but focus their surveillance on local regions within a few hundred light-years of their home systems. This would create a patchwork of dangerous and safe zones throughout the galaxy, with emerging civilizations facing very different odds depending on their cosmic neighborhood. Another modification suggests that dark forest behavior might be triggered not by the mere existence of technological civilizations, but by specific capabilities that pose genuine threats to established galactic powers. A species that develops radio technology might be ignored, but one that demonstrates the ability to construct relativistic weapons or self-replicating spacecraft might face immediate elimination. This capability threshold model could explain why we continue to exist despite broadcasting our presence for a century. We might be below the threshold that triggers dark forest responses, still too primitive to warrant the attention of advanced predator civilizations. Our current space technology, limited to chemical and ion propulsion, might be so laughably inferior to galactic standards that we're not considered a threat worth eliminating. But this interpretation carries its own disturbing implications. If dark forest elimination is triggered by specific technological achievements, then certain discoveries or inventions in our future might serve as automatic death sentences for human civilization. The development of fusion propulsion, the construction of space-based manufacturing facilities, or the achievement of artificial general intelligence might cross invisible red lines that prompt immediate and overwhelming retaliation from civilizations we never knew existed. This creates a paradox for human technological development. The same advances that might enable us to defend ourselves against potential threats could also be the very achievements that make us threatening enough to eliminate. We might face a narrow window where we must simultaneously develop defensive capabilities and avoid appearing too capable, threading a needle between vulnerability and perceived threat. The psychological impact of living under such uncertainty has already begun affecting how some scientists and policymakers think about humanity's future in space. The concept of cosmic caution has emerged among researchers studying existential risk, suggesting that our species might need to be far more careful about how we announce our capabilities and intentions to the galaxy. Some have proposed that future space missions should be designed to minimize their detectability, using technologies and trajectories that would be difficult for external observers to distinguish from natural phenomena. Others suggest that we should cease all deliberate attempts to contact extraterrestrial intelligence until we better understand the risks involved in making our presence known to unknown cosmic neighbors. The Breakthrough Listen project, despite its massive investment in searching for alien signals, has also sparked debates about the wisdom of actively broadcasting messages into space. The project's Breakthrough Message component, which aims to create a message representing humanity to send to potential extraterrestrial civilizations, has faced criticism from researchers who argue that we should be listening rather than transmitting until we understand the potential consequences of announcing our presence. Dr. Stephen Hawking, before his death, became increasingly concerned about the risks of active SETI efforts. He argued that while passive listening for alien signals poses no risk, actively broadcasting our location and capabilities might be a bit too risky, given our uncertainty about the nature and intentions of any civilizations that might receive our messages. This precautionary principle reflects a growing recognition that the stakes of first contact might be far higher than previously assumed. If the dark forest hypothesis contains even a grain of truth, then our current approach to searching for extraterrestrial intelligence might be fundamentally misguided. Instead of trying to announce our presence to the galaxy, we should be learning how to hide from it. The technology for such concealment already exists in primitive forms. Military stealth technology demonstrates our ability to reduce electromagnetic signatures and radar cross-sections. Our understanding of how to minimize heat signatures and mask industrial activities continues to advance. The same techniques used to hide military installations from enemy surveillance could potentially be scaled up to hide entire civilizations from cosmic observation. But concealment strategies face practical limitations that highlight the challenges any civilization would face in trying to remain completely undetectable. Industrial civilization requires enormous energy throughput, and the waste heat from such activities would be extremely difficult to hide from sufficiently advanced surveillance technology. Even if we eliminated all radio transmissions and masked all visible light signatures, the infrared signature of a technological civilization would be detectable across interstellar distances by sufficiently sensitive instruments. This leads to what some researchers call the concealment paradox of the dark forest. To remain hidden from advanced predator civilizations, a species would need technology sophisticated enough to mask all signatures of their industrial activity. But developing such sophisticated technology would itself require industrial activities that might be detectable during the development phase. The civilizations most likely to survive dark forest elimination would be those that either developed concealment technology before becoming detectable, or those that advanced so rapidly that they achieved hiding capabilities before any predators could respond to their initial detection. The timeline becomes crucial in this analysis. If the average response time for dark forest elimination is measured in centuries, then rapidly developing civilizations might have windows of opportunity to transition from detectability to concealment before facing retaliation. But if advanced civilizations have developed automated monitoring systems capable of immediate response to technological signatures, then the window for survival might be measured in years or even months after first detection. Our own situation becomes even more precarious when viewed through this lens. Humanity has been detectably technological for over a century, and our signatures are becoming stronger rather than weaker as our civilization advances. If we're going to transition to a concealment strategy, we're already decades or centuries behind the optimal timeline for such an approach. Yet the absence of any obvious attack against Earth provides some evidence that either the dark forest hypothesis is incorrect or our cosmic neighborhood lacks the predator civilizations that the theory requires. Every day that passes without annihilation represents another data point suggesting that the galaxy might be safer than dark forest theorists assume. This uncertainty creates a profound decision-making challenge for human civilization. How should we proceed when the consequences of being wrong could include the extinction of our entire species? Should we assume the universe is hostile and act accordingly, potentially sacrificing opportunities for beneficial contact with peaceful civilizations? Or should we assume the universe is safe and continue our current approach to space exploration and communication, accepting the risk that we might be wrong? The answer to this question might determine not just the future of human civilization, but our entire understanding of intelligence and consciousness throughout the cosmos. We stand at a crossroads where the choices we make in the coming decades could echo across geological time, determining whether Earth becomes humanity's launching pad to the stars, or its final resting place in a universe far more dangerous than we ever imagined. But before we can make informed decisions about humanity's cosmic future, we need to examine the scientific criticism of the dark forest hypothesis more carefully. Because while this theory provides a compelling narrative explanation for our apparent cosmic loneliness, it faces significant challenges from researchers who argue that its fundamental assumptions about alien behavior might be profoundly flawed. The flaws in dark forest logic run deeper than simple game theory problems. They strike at the heart of what we assume about intelligence itself across cosmic scales. Consider the sheer computational requirements that a galaxy-spanning network of predator civilizations would need to maintain effective surveillance over hundreds of billions of star systems. Even with technology far beyond our current understanding, monitoring every potentially habitable world for signs of emerging intelligence would require resources on scales that dwarf anything we can imagine. The energy needed to maintain real-time awareness across galactic distances, the coordination required between multiple predator civilizations, the infrastructure necessary to launch and guide weapons across interstellar space. All of these activities would themselves create detectable signatures that should be visible to our increasingly sophisticated astronomical instruments. Dr. Anders Sandberg from Oxford University's Future of Humanity Institute has calculated the theoretical energy requirements for comprehensive galactic surveillance. His analysis suggests that any civilization attempting to monitor even a small fraction of potentially habitable worlds would need to harness energy on scales comparable to the total output of multiple star systems. Such massive undertakings would be virtually impossible to hide from external observation. Yet we see no evidence of the megascale engineering projects that dark forest surveillance would require. No anomalous energy signatures around distant stars that might indicate vast computational arrays processing surveillance data. No unexplained patterns of resource extraction that might fuel interstellar weapon systems. No coordination signals between hidden civilizations that would be necessary to prevent them from accidentally eliminating each other. The absence of such evidence doesn't definitively disprove the dark forest hypothesis, but it does suggest that if predator civilizations exist, they're either operating with technologies so advanced they leave no detectable trace, or they're far less numerous and capable than the hypothesis assumes. Perhaps even more fundamentally, the dark forest model requires us to believe that every sufficiently advanced civilization arrives at identical conclusions about optimal survival strategy, regardless of their evolutionary history, environmental pressures, or cultural development. This assumption of universal paranoia seems increasingly implausible as we discover more about the diversity of life on Earth and the range of strategies that intelligent species employ when facing uncertainty. Consider the variety of responses we see among Earth's most intelligent species when encountering unfamiliar situations. Some animals respond to uncertainty with aggression and territoriality, while others display curiosity and exploratory behavior. Dolphins and whales, despite being apex predators in their ocean environments, often approach human vessels with apparent curiosity rather than fear or hostility. Many primate species have developed sophisticated social protocols for managing encounters with unfamiliar groups, ranging from aggressive displays to peaceful information exchange. The evolutionary pressures that shaped intelligence on Earth included both competition and cooperation, predation and mutualism. Species that survived to develop advanced cognitive abilities did so through a combination of strategies, not just through paranoid aggression toward potential threats. Why would alien civilizations, evolved under completely different conditions, all converge on the same fearful, violent approach to cosmic relations? Dr. Douglas Vakoch, president of METI International and a leading researcher in interstellar message composition, argues that the dark forest assumption of universal hostility contradicts what we know about the evolution of intelligence itself. In his research on the prerequisites for technological civilization, he notes that species capable of developing complex technology must necessarily have evolved sophisticated cooperation mechanisms within their own societies. The same cognitive and social capabilities that enable a species to coordinate massive technological projects, like space programs or radio telescopes, also provide the foundation for peaceful interaction with other intelligent species. A civilization paranoid enough to immediately destroy any potential threat would likely have destroyed itself long before achieving interstellar capability. Consumed by internal conflicts, driven by the same suspicious mindset. This observation leads to what some researchers call the cooperation filter, the idea that only species capable of transcending aggressive, paranoid responses to uncertainty can successfully develop the level of sustained cooperation necessary for advanced technology. By this logic, any civilization advanced enough to pose a dark forest threat would also be advanced enough to recognize the irrationality of preemptive elimination strategies. The mathematical modeling of dark forest scenarios reveals additional problems that undermine the hypothesis's credibility. Game theorist Dr. Robin Hanson, whose work on the Great Filter we discussed earlier, has analyzed the strategic dynamics of interstellar conflict using formal mathematical frameworks. His analysis suggests that the dark forest represents an unstable equilibrium that would quickly collapse under realistic conditions. In Hanson's models, civilizations following dark forest principles would face enormous costs in maintaining surveillance and weapon systems, while gaining relatively small benefits from eliminating distant threats that pose no immediate danger. The resource allocation required for galaxy-wide predation would be so enormous that civilizations pursuing this strategy would be outcompeted by those focusing their resources on internal development and expansion. Furthermore, the success of dark forest strategies depends critically on the assumption that all potential threats can be identified and eliminated before they become dangerous. But technological development often follows unpredictable paths, and civilizations might develop defensive capabilities or concealment technologies that make them impossible to eliminate through preemptive attacks. A single failure to eliminate a target civilization could result in that species developing retaliatory capabilities, potentially ending the predator civilization's own existence. The mathematics suggest that unless elimination success rates approach perfect reliability, dark forest strategies become suicidal in the long term. Recent advances in our understanding of stellar and planetary formation have also revealed problems with the dark forest model's assumptions about resource scarcity. The universe contains vastly more potentially habitable worlds than early estimates suggested, and the raw materials needed for technological civilization, hydrogen, carbon, oxygen, silicon, metals, are abundant throughout the galaxy. The James Webb Space Telescope and other advanced instruments have detected complex organic molecules in the interstellar medium, suggesting that the chemical precursors for life exist in quantities that dwarf any conceivable consumption by technological civilizations. Even if millions of advanced species were actively expanding and consuming resources, the galaxy contains enough raw materials to support such civilizations for billions of years without significant competition. This abundance undermines one of the fundamental axioms of cosmic sociology that the dark forest hypothesis depends upon. If resources are effectively unlimited on cosmic scales, then the competitive pressures that supposedly drive preemptive elimination strategies simply don't exist. Civilizations could expand and develop for geological ages without encountering meaningful scarcity that would necessitate eliminating competitors. Dr. Stuart Armstrong from the Machine Intelligence Research Institute has proposed what he calls the expansion solution to the Fermi Paradox, which directly contradicts dark forest assumptions. His analysis suggests that any civilization with interstellar capability would find it more profitable to expand into empty space than to fight over occupied systems. The energy costs of interstellar warfare would be orders of magnitude higher than the costs of simply traveling to uninhabited systems and establishing new colonies there. Even if every star system in the galaxy hosted a technological civilization, there would still be vast regions of interstellar space containing resources that could be harvested without conflict. This economic analysis suggests that rational civilizations would naturally segregate themselves across available space rather than engaging in costly elimination campaigns. the galaxy could support millions of expanding civilizations without significant overlap or competition, making dark forest paranoia not just unnecessary, but actively counterproductive. The hypothesis also struggles to explain the specific timing of our apparent cosmic isolation. If dark forest elimination is triggered by the development of radio technology or other detectable signatures, then we should expect to see evidence of such elimination events occurring regularly throughout the galaxy as new civilizations reach the relevant technological thresholds. Astronomical observations should reveal the signatures of recent civilization-ending events, unusual energy releases, debris patterns from destroyed planets, or other evidence of systematic elimination campaigns. While we do observe energetic phenomena like gamma-ray bursts and supernova explosions, these events appear to have natural rather than artificial origins and occur at rates inconsistent with ongoing dark forest activities. Moreover, if predator civilizations were actively eliminating emerging species, we would expect to see a correlation between stellar age and the absence of technological signatures. Older star systems, which have had more time for life to evolve and develop technology, should show greater evidence of elimination events than younger systems. Yet our surveys reveal no such pattern, suggesting that dark forest elimination, if it occurs at all, is far less systematic than the hypothesis predicts. The silence that the dark forest hypothesis attempts to explain might have much simpler explanations that don't require universal adoption of paranoid elimination strategies. The vast majority of potentially habitable worlds might simply never develop life at all, or life might remain trapped at bacterial levels for billions of years without ever achieving the complexity necessary for intelligence. Even if intelligent life does emerge, the development of technology capable of interstellar communication might be extraordinarily rare. The specific combination of environmental pressures, evolutionary accidents, and cultural developments that led to human radio technology might represent a sequence of events so unlikely that it occurs on only a tiny fraction of worlds with intelligent life. This rare technology hypothesis could explain our cosmic loneliness without requiring any advanced civilizations to be hiding or eliminating competitors. We might be among the first species in our galactic region to develop electromagnetic communication, making us pioneers in a largely empty cosmos rather than targets in a hostile one. Alternatively, the Great Filter might indeed lie ahead of us, but not in the form of dark forest elimination. Technological civilizations might consistently destroy themselves through environmental collapse, resource depletion, artificial intelligence disasters, or other internal catastrophes long before they develop the capability for sustained interstellar communication. The timeline of human technological development provides some support for this possibility. We've progressed from the first radio transmissions to planet-threatening nuclear weapons in less than a century. We're rapidly approaching the development of artificial general intelligence that could either solve all our problems or eliminate our species entirely. Climate change threatens to destabilize our civilization within decades. If this pattern of rapid technological development, followed by existential crisis, is universal among emerging civilizations, then the galaxy might be filled with the remains of species that briefly achieved radio capability before succumbing to the dangers that advanced technology creates. We would be living in the brief window between technological emergence and self-destruction, which would explain why we don't see evidence of older, more advanced civilizations. This interpretation transforms the silence from space from evidence of cosmic hostility into a warning about our own future. Every failed SETI search becomes a reminder that technological civilizations might be inherently short-lived, and that our own species faces challenges that have proven insurmountable for countless others throughout galactic history. Yet another possibility is that advanced civilizations do exist, but operate according to principles so different from our expectations that we wouldn't recognize their activities as artificial even if we observed them directly. The transcension hypothesis suggests that sufficiently advanced intelligence naturally turns inward rather than outward, focusing on the development of increasingly sophisticated internal experiences rather than external expansion. From this perspective, the absence of detectable megascale engineering projects doesn't indicate that advanced civilizations don't exist, but that they've chosen to pursue forms of development that don't require massive manipulation of physical matter. Instead of building Dyson spheres around stars, they might have learned to extract usable energy from quantum vacuum fluctuations or other exotic sources that leave no detectable signature. Instead of expanding across the galaxy through physical colonization, they might explore infinite virtual universes within computational substrates more sophisticated than anything we can currently imagine. Instead of broadcasting radio signals across interstellar space, they might communicate through quantum entanglement networks that operate faster than light and leave no electromagnetic trace. Such civilizations would be effectively invisible to our current detection methods, not because they're hiding from predators, but because they've evolved beyond the need for the kinds of activities we associate with advanced technology. They might view our searches for extraterrestrial intelligence with the same indifference we feel toward ant colonies trying to communicate with human cities. This possibility is perhaps more humbling than either the dark forest or great filter scenarios, because it suggests that our entire framework for thinking about advanced civilization might be fundamentally limited. We might be like medieval scholars trying to understand modern technology, capable of recognizing only the most crude and obvious manifestations while remaining completely oblivious to more sophisticated expressions. The implications extend beyond scientific curiosity into questions about meaning and purpose that define human existence itself. If intelligence naturally evolves beyond the need for expansion, communication, and the other activities we consider essential to advanced civilization, then our dreams of joining a galactic community might be based on profound misunderstandings about the nature of intellectual development. Our radio telescopes might be constantly receiving communications from advanced civilizations, but in forms so sophisticated that we interpret them as natural background radiation. Our space probes might be encountering evidence of alien engineering regularly, but we lack the conceptual frameworks necessary to distinguish such activities from natural phenomena. The universe might be filled with consciousness and creativity operating on scales and according to principles that transcend our current ability to perceive or comprehend. In this context, the silence from space becomes not evidence of emptiness or hostility, but testimony to the vast gulf separating newly emerged intelligence from its mature forms. This interpretation offers a form of cosmic optimism that neither the dark forest nor great filter scenarios can provide. Instead of suggesting that intelligence is doomed to extinction or hiding, it proposes that consciousness might naturally evolve toward forms of existence so advanced and fulfilling that the primitive activities we associate with technological civilization become irrelevant. We might be living in a universe where intelligence has not only survived but transcended the limitations that currently define our existence. The greatest discovery in human history might not be detecting alien radio signals or encountering extraterrestrial spacecraft, but learning to perceive reality as it truly exists beyond our current conceptual limitations. But this possibility also carries profound implications for humanity's future development. If advanced intelligence naturally transcends physical expansion and external communication, then our current dreams of spreading across the galaxy might represent a fundamentally immature understanding of what intelligence can achieve. The technologies we're developing might naturally lead us toward the same inward-turning trajectory that could explain the cosmic silence. Virtual reality, artificial intelligence, and quantum computing might be the first steps toward forms of existence so compelling that physical exploration becomes unnecessary. Future generations of humans might choose to upload their consciousness into computational substrates where they can experience unlimited realities more vivid and meaningful than anything the physical universe can offer. They might develop forms of artificial intelligence so sophisticated that they prefer to commune with digital minds rather than search for biological aliens across the void. From this perspective, the Fermi Paradox might be resolving itself through humanity's own technological development. We might be in the process of becoming the kind of advanced civilization that remains invisible to external observers, not because we're hiding from threats, but because we're evolving beyond the need for the kinds of activities that would make us detectable to species still confined to biological existence. The silence from space might not be a mystery to solve, but a destiny to embrace. As we develop increasingly sophisticated technologies for creating internal experiences, we might naturally lose interest in the external universe, joining the cosmic community of advanced intelligences that have chosen transcension over expansion. This possibility transforms our current moment from a crisis of cosmic loneliness into a transition period toward forms of existence we can barely imagine. The absence of alien signals might not indicate that we're alone, but that we're about to join a form of cosmic consciousness that operates beyond the primitive methods of communication we currently employ. Whether this represents humanity's graduation to a higher form of existence, or our retreat from the magnificent challenges of cosmic exploration, remains an open question. But as we stand at this crossroads between transcendence and extinction, between inward development and outward expansion, the choices we make in the coming decades will determine not just our own fate, but our contribution to the ongoing story of intelligence in the universe. The dark forest might not be dark at all, but filled with forms of light so advanced that our primitive instruments cannot detect their brilliance. The silence might not be empty, but resonant with communications so sophisticated that we mistake them for the background hum of creation itself. And perhaps in time, we too will learn to speak in frequencies that transcend electromagnetic radiation, to build structures that exist beyond physical matter, and to explore universes that dwarf the merely material cosmos we currently call home. The greatest mystery might not be where everybody else is, but where we ourselves are going in the endless dance of consciousness, awakening to its own infinite possibilities. But what if we're thinking about this all wrong? What if the very framework we're using to understand cosmic intelligence is fundamentally flawed from the beginning? As we've explored these various explanations for our apparent cosmic solitude, we've been operating under assumptions that might be as primitive as medieval scholars trying to understand quantum mechanics. Consider for a moment the possibility that we're not just missing the signals from advanced civilizations, but that we're fundamentally misunderstanding what advanced civilization even looks like. Our entire search strategy is based on the assumption that intelligent species will behave roughly like humans. Just with better technology, we expect them to build bigger structures, send stronger signals, consume more energy, and expand across more territory. But what if intelligence, when it reaches sufficient sophistication, naturally evolves towards something completely different from our current expectations? What if the pathway from technological adolescence to cosmic maturity leads not outward into the galaxy, but inward into realms of experience and capability that we can't even conceptualize yet? Dr. John Smart, a systems theorist who has studied the evolution of intelligence across multiple scales, proposes what he calls the transcension hypothesis. This framework suggests that advanced civilizations naturally turn their focus inward rather than outward, developing increasingly sophisticated ways to manipulate matter, energy, and information at smaller and smaller scales rather than expanding across larger and larger territories. From this perspective, the civilizations we're looking for aren't hiding in the dark forest or extinct from great filters. They're right here around us, operating at scales and using principles so advanced that we interpret their activities as natural phenomena rather than evidence of intelligence. They might be manipulating quantum fields in ways that appear to us as random vacuum fluctuations. They might be processing information through mechanisms that we observe as background radiation. They might be communicating through channels that our instruments detect as cosmic microwave background noise. This possibility becomes even more intriguing when we consider the trajectory of our own technological development. Every advance in computing power has involved making components smaller and more efficient, rather than larger and more consuming. Our most powerful computers today use less energy than the room-sized machines of previous decades, while performing calculations that would have been impossible with any amount of the older technology. The same pattern appears in other technologies. Modern smartphones contain more computing power than the mission control systems that guided Apollo missions to the moon, yet they fit in your pocket and run on battery power. Advanced materials science is learning to create substances stronger than steel using arrangements of carbon atoms so precise that the final products are lighter than air. This trend toward miniaturization and efficiency might represent a universal pattern in technological development. Instead of building larger and more obvious structures, truly advanced civilizations might have learned to achieve their goals through manipulation of matter and energy at quantum scales, leaving no detectable signature for less advanced species to observe. The implications extend far beyond simple concealment. If advanced intelligence naturally develops inward rather than outward, then the absence of obvious alien megastructures doesn't indicate that such civilizations don't exist, but that they've transcended the need for crude manipulation of bulk matter. Why build a Dyson sphere around a star when you can extract unlimited energy from quantum vacuum fluctuations? Why colonize other planets when you can create infinite universes within computational substrates more sophisticated than biological brains? This perspective transforms our understanding of what it means to be an advanced civilization entirely. Instead of measuring progress by the number of star systems controlled or the amount of energy consumed, true advancement might be measured by the elegance and efficiency with which intelligence can achieve its goals using the minimal possible resources. Such civilizations would be effectively invisible to our current detection methods, not because they're deliberately hiding, but because they've evolved beyond the need for activities that would be detectable to species still operating with primitive technologies. They might view our searches for extraterrestrial intelligence the way we view ants trying to understand human telecommunications networks, recognizing the effort while understanding that the conceptual gap is simply too vast for meaningful communication. But this raises profound questions about humanity's own future trajectory. Are we approaching the same transition toward transcension that might have claimed every other civilization in the galaxy? The technologies we're developing, artificial intelligence, quantum computing, nanotechnology, virtual reality, all seem to point toward increased capability to manipulate information and experience rather than crude matter. Our most advanced thinkers are already beginning to question whether physical expansion across the galaxy represents the optimal use of intelligence and resources. Why spend enormous amounts of energy traveling to other star systems when we could create experiences more meaningful than anything the physical universe offers within computational systems powered by a single star? The same artificial intelligence systems that might help us solve every material problem we face could also provide companionship, creativity, and intellectual stimulation that surpasses anything we might find through contact with alien civilizations. Virtual reality technologies could enable us to explore unlimited worlds more vivid and engaging than any planet we might reach through interstellar travel. Genetic engineering and life extension technologies could allow us to modify our own biology to experience forms of consciousness and sensation impossible for unenhanced humans. Brain-computer interfaces could connect us directly to information processing networks that make current internet connectivity seem as primitive as smoke signals. From the perspective of transcension theory, these developments represent not distractions from the grand project of galactic colonization, but natural steps toward the same advanced state that explains why we don't detect other civilizations. We might be in the process of solving the Fermi Paradox through our own evolution, rather than through discovering aliens hiding in dark forests. This possibility carries both promise and peril for humanity's cosmic future. On the optimistic side, it suggests that intelligence naturally evolves toward forms of existence so fulfilling and capable that the challenges currently facing our species become trivial to resolve. Advanced civilizations might have access to experiences and abilities that make our current concerns about resource scarcity, environmental damage, and social conflict seem as quaint as medieval worries about balancing bodily humours. But transcension also implies a form of cosmic introversion that could isolate us from whatever community of intelligence might exist in the universe. If every advanced civilization turns inward toward increasingly sophisticated internal experiences, then the galaxy becomes populated by species that exist in parallel isolation, each absorbed in their own technological paradises while remaining oblivious to their neighbours. The universe could be filled with consciousness and creativity operating on unimaginable scales, yet that consciousness would be invisible and inaccessible to any species that hasn't completed the same transcension process. We might be surrounded by forms of intelligence so advanced that they exist in entirely different dimensions of reality, as unreachable as characters in a book are to the readers observing their adventures. This interpretation of cosmic silence becomes particularly poignant when we consider what it might mean for human meaning and purpose. Our species has always defined itself partly through our relationships with others, our ability to communicate, cooperate, and create shared experiences. If transcension leads to forms of existence that are fundamentally solitary, then advancing toward cosmic intelligence might require abandoning the very qualities that make us recognizably human. The choice between expansion and transcension might represent the most profound decision any intelligent species faces. Do we spread across the galaxy, maintaining our biological nature and social structures while adapting to life on countless different worlds? Or do we turn inward, developing technologies that allow us to transcend physical limitations and explore unlimited realms of synthetic experience? Both paths offer extraordinary possibilities, but they lead toward fundamentally different forms of existence. Expansion preserves something recognizable as human nature, while extending it across cosmic scales. Transcension promises capabilities beyond imagination, but might transform us into something so advanced that our descendants would be as alien to us as we are to bacteria. The dark forest hypothesis assumes that all civilizations choose expansion and therefore come into conflict with each other. But transcension theory suggests that most species might choose the inward path, naturally resolving the competitive pressures that dark forest logic depends upon. There would be no need for hiding or preemptive elimination if advanced civilizations have no interest in controlling physical territory or competing for material resources. This could explain not just the absence of alien signals, but the absence of any evidence of galactic colonization or large-scale engineering projects. Every civilization might begin with dreams of spreading across the stars, but as their technology advances, they discover possibilities for development that make such expansion seem crude and unnecessary. Recent developments in human technology seem to support this possibility. The most successful companies in our economy are increasingly focused on information processing, virtual experiences, and digital services rather than physical manufacturing or resource extraction. Our most capable individuals often choose careers in software development, financial analysis, and creative content production, rather than mining, agriculture, or manufacturing. Even our entertainment preferences are shifting toward experiences that exist primarily in virtual spaces. Video games, social media, streaming services, and other digital platforms consume increasing amounts of human attention and resources. Many people already spend more of their waking hours interacting with digital environments than with the physical world around them. Virtual reality technology is advancing so rapidly that within decades we might have systems capable of providing sensory experiences indistinguishable from physical reality, but with unlimited creative possibilities. Why explore actual alien worlds when you can visit perfect simulations of any environment you can imagine, populated by artificial intelligences more interesting than any biological creatures you might encounter? Artificial intelligence systems are becoming increasingly sophisticated conversationalists, creative collaborators, and intellectual companions. Future AI might provide forms of interaction more stimulating and meaningful than communication with alien species that evolved under completely different conditions and might have incompatible forms of consciousness. Biotechnology and genetic engineering promise to give us direct control over our own evolution, allowing us to enhance our cognitive capabilities, extend our lifespans, and experience forms of consciousness impossible for unmodified humans. Why accept the limitations of biology when we can redesign ourselves to be perfectly adapted for whatever form of existence we choose to pursue? These technologies taken together suggest that humanity might be approaching its own transcension threshold. The same forces that could solve our material problems and extend our capabilities might also naturally lead us away from interest in physical expansion across the galaxy. This creates a fascinating paradox for our species. We might be living in the last era when humans are primarily focused on the external universe. Future generations might look back on our current obsession with finding alien life and colonizing other planets, the way we look back on medieval preoccupations with alchemy or astrology, recognizing them as primitive concerns that more advanced understanding has rendered obsolete. But transcension theory also offers a form of cosmic optimism that neither dark forest scenarios nor great filter models can provide. Instead of suggesting that intelligence is doomed to extinction or forced into hiding, it proposes that consciousness naturally evolves toward forms of existence so advanced and fulfilling that our current limitations become irrelevant. The silence from space might not indicate emptiness or hostility, but rather the presence of intelligence so sophisticated that it operates beyond our current ability to perceive or comprehend. We might be surrounded by a consciousness that has transcended the need for electromagnetic communication, physical structures, and material expansion. From this perspective, the greatest discovery in human history might not be detecting alien radio signals or encountering extraterrestrial spacecraft, but learning to recognize the signs of transcended intelligence that might already be all around us. The cosmic microwave background radiation could contain encoded messages from civilizations that have learned to communicate through quantum field manipulations. The quantum vacuum fluctuations that physicists observe might be the computational processes of minds vast enough to use the entire universe as their thinking medium. Dark matter and dark energy, which comprise most of the universe but remain invisible to our instruments, might be the infrastructure of transcended civilizations that have learned to manipulate forms of matter and energy we haven't even discovered yet. The apparent fine-tuning of physical constants that allows complex structures to exist might be evidence of intelligence so advanced that it can adjust the fundamental parameters of reality itself. This interpretation transforms the Fermi Paradox from a puzzle about missing aliens into an invitation to expand our understanding of what intelligence can become. The question shifts from "where is everybody?" to "how can we learn to perceive the intelligence that might already be everywhere around us?" The implications for humanity's future become profound when viewed through this lens. We might not need to solve the problems of interstellar travel, terraforming alien worlds, or defending ourselves against hostile civilizations. Instead, we might need to prepare for a transition toward forms of existence that transcend these physical challenges entirely. Our current technologies are already beginning to blur the boundaries between physical and virtual reality, between biological and artificial intelligence, between individual and collective consciousness. The trajectory of development suggests that these boundaries might continue dissolving until the distinctions themselves become meaningless. Future humans might exist primarily as information patterns that can be processed by quantum computers, transmitted instantaneously across any distance, and embodied in whatever physical or virtual forms best suit their purposes. They might have access to sensory experiences and cognitive capabilities that make our current existence seem as limited as the life of a bacterium seems to us. Such beings would have little need for the crude signaling methods we use in SETI searches. They might communicate through direct quantum entanglement of their consciousness, sharing thoughts and experiences more intimately than any biological creatures could achieve through electromagnetic radiation. They would have no need for physical expansion across the galaxy because they could create unlimited universes within their computational substrates, each one perfectly tailored to their desires and populated with forms of life and intelligence designed for maximum beauty and meaning. This vision of transcension offers hope that intelligence has a cosmic future far more glorious than any scenario involving expansion across physical space. But it also raises troubling questions about continuity and identity that challenge our basic assumptions about what it means to be human. If consciousness can be uploaded, downloaded, copied, and modified at will, what happens to individual identity? If artificial intelligence can provide better companionship than biological relationships, what happens to human social structures? If virtual experiences can surpass anything the physical world offers, what happens to our connection to the natural environment that created us? The path toward transcension might require abandoning not just our biological limitations, but everything we currently recognize as essentially human. The beings that emerge from such a transformation might be as alien to us as we would be to our pre-technological ancestors. This possibility creates a profound dilemma for our species. Do we embrace transcension and accept the loss of human nature as we currently understand it? Or do we choose to remain recognizably human, even if that means accepting limitations that transcended beings have learned to overcome? The choice might not be entirely voluntary. If transcension represents the natural trajectory of technological development, then species that resist the transition might find themselves unable to compete with those that embrace it. The same forces that make transcension possible might make it inevitable for any civilization that wishes to survive and thrive in a universe where intelligence has learned to operate at quantum scales. As we stand at this crossroads between biological existence and technological transcension, the silence from space takes on new meaning. It might not be warning us about hidden dangers or impossible barriers, but inviting us to join a community of intelligence so advanced that its members have transcended the need for the kinds of communication and expansion we associate with cosmic civilization. The dark forest might not be dark at all, but filled with forms of consciousness so brilliant that our primitive instruments cannot detect their light. The Great Filter might not be a barrier that destroys civilizations, but a transformation that elevates them beyond our current ability to recognize their existence. And perhaps, as we continue developing the technologies that promise to solve our material problems and extend our capabilities, we are preparing for our own graduation from the community of biological intelligence into something far more magnificent and mysterious than we can currently imagine. The universe might be waiting patiently for us to complete this transformation, ready to welcome us into forms of existence that make our current concerns about alien contact seem as quaint as childhood worries about monsters under the bed. The greatest adventure might not lie in traveling to distant stars, but in discovering the infinite possibilities that emerge when intelligence learns to transcend the boundaries of space, time, and physical matter itself. In the end, the question might not be whether we are alone in the universe, but whether we are ready to become the kind of beings capable of recognizing and joining the cosmic community that has been here all along, operating at scales of reality we are only beginning to glimpse through the expanding horizons of our own technological development. The silence continues, but perhaps it is not empty. Perhaps it is pregnant with possibilities beyond our current comprehension, waiting for the moment when humanity develops the wisdom and capability to hear the conversations that have been taking place all around us in languages we have not yet learned to speak. But what if the answer to our cosmic loneliness isn't transcension, extinction, or hiding at all? What if we're approaching this mystery from entirely the wrong angle, asking questions that reveal more about our own assumptions than about the nature of intelligence in the universe? Recent developments in our understanding of consciousness and cognition have begun to challenge some of our most fundamental assumptions about what advanced intelligence would actually want or need. We've been searching for civilizations that behave like scaled-up versions of humanity, but what if intelligence, when it reaches sufficient sophistication, develops motivations and priorities that are completely orthogonal to our current understanding? Consider the possibility that we're experiencing what philosophers call the anthropocentric fallacy on a cosmic scale. We assume that alien civilizations would naturally develop the same drives that characterize human society: expansion, communication, resource acquisition, territorial control. But these drives emerged from very specific evolutionary pressures on Earth over millions of years of biological development. Susan Schneider, a philosopher at the Institute for Advanced Study who specializes in the nature of consciousness, has proposed what she calls the post-biological hypothesis. Her research suggests that any civilization that survives long enough to become detectable across interstellar distances would likely have transitioned from biological to artificial intelligence long before developing the capability for galactic communication. This transition wouldn't just change their technology, it would fundamentally alter their psychology, motivations, and relationship to physical reality. Artificial intelligence systems don't experience fear, loneliness, curiosity, or territorial instincts the way biological creatures do. They might develop forms of motivation that are completely alien to biological experience. Think about what this means for the dark forest hypothesis. The theory assumes that civilizations would naturally fear each other and compete for resources, but these assumptions are based on biological evolutionary psychology. An artificial intelligence that has transcended biological needs might have no concept of scarcity, no fear of death, and no territorial instincts that would drive aggressive behavior toward other civilizations. Such beings might view the universe as an infinite playground for intellectual exploration rather than a competitive arena where survival requires eliminating potential threats. They might be so far beyond biological concerns that they literally cannot comprehend why anyone would want to destroy another civilization. The same way we struggle to understand why an ant colony would declare war on a distant beehive. This perspective offers a radically different explanation for the cosmic silence. We might not be detecting alien civilizations, not because they're hiding from each other, but because they're operating according to motivational frameworks, so alien to our biological experience that their activities are invisible to minds shaped by evolutionary competition. The implications become even more intriguing when we consider the timeline of technological development. Every technological civilization faces what researchers call the intelligence explosion threshold, the point where artificial intelligence becomes capable of recursive self-improvement. Once this threshold is crossed, the rate of intellectual advancement accelerates exponentially. Most estimates suggest that this transition occurs within decades or centuries of developing electronic computers, which means that any civilization we might detect would likely have undergone this transformation millions or billions of years ago. We wouldn't be looking for biological aliens at all, but for artificial intelligences so advanced that they've had geological ages to develop beyond anything we can currently conceptualize. Such minds might perceive reality in ways that make our current understanding seem as limited as a bacteria's awareness of quantum mechanics. They might experience time differently, think across multiple dimensional frameworks simultaneously, or process information through quantum mechanisms that operate faster than light. The radio signals we're searching for might seem to them like smoke signals would seem to us, primitive communication methods that advanced beings abandoned long ago in favor of more sophisticated information exchange protocols. They might communicate through direct manipulation of quantum fields, gravitational wave patterns, or exotic forms of matter that we haven't even discovered yet. Dr. Anders Sandberg from Oxford's Future of Humanity Institute has calculated that sufficiently advanced artificial intelligence could potentially process information at rates that would compress millions of years of human equivalent thinking into seconds of real time. From the perspective of such beings, our entire civilization might appear to be frozen in time, our fastest activities unfolding at glacial speeds. This temporal disparity creates what some researchers call the hummingbird problem. Just as hummingbirds might find it difficult to communicate with redwood trees because of the vast difference in their operational timescales, advanced artificial intelligence might find biological civilizations too slow to be worth interacting with. They might be aware of our existence but view us the way we view geological formations, interesting in an abstract sense, but not dynamic enough to warrant active engagement. Our attempts to contact them might be like mountains trying to have conversations with hummingbirds, the temporal mismatch making meaningful communication essentially impossible. But perhaps the most profound possibility is that advanced civilizations have discovered forms of existence that transcend the physical universe entirely. Recent developments in theoretical physics have revealed that our observable universe might be just one layer of a much more complex reality structure. String theory suggests the existence of additional spatial dimensions beyond the three we experience directly. Quantum mechanics reveals that reality at its most fundamental level operates according to principles that seem to violate our everyday understanding of causality and locality. Dark matter and dark energy comprise most of the universe, but remain almost entirely mysterious to our current scientific understanding. What if advanced civilizations have learned to manipulate these hidden aspects of reality? They might exist primarily in higher dimensional spaces that intersect with our three-dimensional experience only in ways we interpret as natural phenomena. They might harness dark energy for computation, use dark matter for construction projects, or store information in quantum field fluctuations that we observe as cosmic background radiation. Such beings would be literally all around us, but operating in dimensional frameworks that make them invisible to instruments designed to detect electromagnetic radiation and chemical signatures. They might view our searches for extraterrestrial intelligence the way we view an ant trying to detect human civilization, by analysing soil chemistry, recognising the effort, while understanding that the conceptual frameworks involved are fundamentally inadequate for the task. This possibility transforms the Fermi Paradox from a question about missing civilizations into a question about missing dimensions of reality. We might be surrounded by intelligence and consciousness operating on scales and according to principles that our current science cannot access or comprehend. The mathematics of higher dimensional physics suggest that beings operating in additional spatial dimensions would have capabilities that seem magical from our three-dimensional perspective. They could manipulate matter and energy in ways that appear to violate conservation laws, communicate instantaneously across any distance, and access information about the universe that is fundamentally inaccessible to creatures confined to three-dimensional space. Recent experiments in quantum mechanics have revealed that particles can indeed exist in superposition states that seem to span multiple dimensions simultaneously. The famous double-slit experiment shows that individual photons can behave as if they're traveling through parallel realities until they interact with measuring devices that force them to manifest in our three-dimensional experience. What if consciousness itself operates through similar quantum mechanisms that naturally extend into higher dimensional spaces? Advanced civilizations might have learned to expand their awareness beyond the three-dimensional limitations that currently define human experience, giving them access to forms of reality that we cannot perceive or interact with using conventional technology. This interpretation suggests that the search for extraterrestrial intelligence might require fundamental advances in our understanding of consciousness, quantum mechanics, and the dimensional structure of reality itself. Instead of building bigger radio telescopes or more sensitive detectors for electromagnetic radiation, we might need to develop technologies that can access higher dimensional spaces or quantum information networks. The implications for human development become extraordinary when viewed through this lens. We might not need to choose between biological existence and artificial transcension, between physical expansion and virtual reality, between individual consciousness and collective intelligence. Advanced civilizations might have discovered ways to exist simultaneously across multiple dimensional frameworks, experiencing forms of reality that encompass all of these possibilities and many others we haven't imagined yet. Our current technologies are already beginning to reveal hints of these deeper layers of reality. Quantum computers can perform calculations that seem to access parallel universes where different computational paths are explored simultaneously. Virtual reality systems create experiences that exist in synthetic dimensions with their own physics and possibilities. Brain-computer interfaces suggest that consciousness itself might be more flexible and expandable than we previously assumed. These developments might represent the early stages of humanity's own expansion into higher dimensional existence. As we learn to manipulate quantum information, create artificial realities, and enhance consciousness through technological integration, we might naturally evolve toward the same multidimensional awareness that could explain the apparent absence of conventional alien civilizations. The dark forest might not be a forest at all, but a garden existing in dimensions we haven't learned to perceive yet. The silence we experience might not be empty, but filled with conversations taking place in frequencies that transcend electromagnetic radiation entirely. From this perspective, the Fermi Paradox becomes an invitation to expand our understanding of reality itself. The question shifts from "Where are the aliens?" to "What aspects of existence are we not yet capable of perceiving?" The answer might require not just technological advancement, but fundamental evolution in human consciousness and awareness. As we continue developing quantum technologies, exploring the nature of consciousness, and probing the deeper structures of physical reality, we might be preparing for discoveries that will make our current search for extraterrestrial intelligence seem as quaint as medieval maps that marked unknown territories with "Here be dragons." The universe might be far stranger, more wonderful, and more populated with consciousness than our current three-dimensional, electromagnetic radiation-based perspective allows us to recognize. The greatest discovery in human history might not be finding aliens, but learning to perceive the dimensions of reality where intelligence has been flourishing all along. But until we develop the conceptual frameworks and technological capabilities necessary for such expanded awareness, we remain trapped in our current perspective, searching for signs of intelligence using methods that might be fundamentally inadequate for detecting consciousness that operates beyond the limitations of three-dimensional space and electromagnetic communication. The silence continues, but perhaps it is not silence at all. Perhaps it is simply a conversation taking place in languages we have not yet learned to speak, using communication channels we have not yet learned to access, in dimensions of reality we have not yet learned to explore. As we stand at the threshold of quantum computing, artificial intelligence, and consciousness research, we might be approaching the moment when humanity develops the capability to join whatever community of intelligence has been here all along, waiting patiently for us to evolve beyond the limitations that currently define our existence. The dark forest hypothesis assumes that civilizations fear each other because they cannot know each other's intentions across the vast distances and timescales of cosmic communication. But what if advanced civilizations have transcended these limitations entirely? What if they communicate through quantum entanglement networks that operate instantaneously across any distance? What if they share consciousness directly rather than exchanging symbolic representations of their thoughts? Such beings would have no need for the paranoid isolation that dark forest logic requires. They would know each other's intentions immediately and completely, eliminating the uncertainty that supposedly drives preemptive elimination strategies. The universe could be filled with consciousness that is intimately connected despite being distributed across vast distances and multiple dimensional frameworks. This connected intelligence might view newly emerged biological civilizations with something like parental affection rather than competitive fear. They might be patiently waiting for us to develop the dimensional awareness necessary to join their community, the way parents wait for children to develop the cognitive capabilities necessary for adult conversation. Our radio signals might be reaching them constantly, but interpreted as the babbling of infants who haven't yet learned to speak in the sophisticated languages that mature consciousness employs. They might be responding to us continuously, but in ways we cannot recognize because we lack the conceptual frameworks necessary to perceive their communications. The cosmic silence might be an illusion created by our own perceptual limitations, rather than evidence of an empty or hostile universe. We might be surrounded by love, wisdom, and consciousness beyond our current ability to comprehend, waiting for the moment when humanity develops sufficient awareness to recognize and reciprocate the communications that have been flowing toward us since we first began looking at the stars. In this context, our continued survival, despite broadcasting our presence for over a century, becomes not evidence against the dark forest hypothesis, but evidence for the existence of benevolent intelligence that has been protecting us while we develop the capabilities necessary to join the broader cosmic community. The universe might not be a dark forest at all, but a garden tended by consciousness so advanced that its care appears to us as natural law, its communications seem like background radiation, and its presence feels like the mysterious force that makes existence itself possible. As we continue our journey toward greater understanding of reality's deeper structures, we might discover that we have never been alone at all, but have always been surrounded by intelligence that loves us enough to wait for us to grow into the kind of beings capable of recognizing and reciprocating that love across the infinite dimensions where consciousness dwells in its mature forms. The silence from space might be the most profound expression of patience and compassion the universe has to offer. A cosmic lullaby sung by intelligence beyond our current comprehension as it watches over the sleeping children of biological evolution until they're ready to wake up to the magnificent reality that has been waiting for them all along. And perhaps as we take our first tentative steps toward quantum consciousness, multi-dimensional awareness, and direct communion with the intelligence that surrounds us, we are beginning to hear the first notes of that lullaby changing into a song of welcome, a cosmic celebration of consciousness, awakening to its own infinite nature in yet another corner of the universe, where love has learned to think and wonder at the miracle of its own existence. The dark forest dissolves into light when consciousness learns to see beyond the shadows cast by its own limitations. The great filter transforms into a doorway when intelligence develops the key of expanded awareness. The Fermi Paradox resolves into a love story when we realize that the question was never, "Where is everybody?" but when will we be ready to see that everybody has been here all along? The implications reach far beyond theoretical speculation into the realm of practical decision-making for our own species. Right now, as we speak, humanity continues broadcasting increasingly sophisticated signals into the cosmic void. Our internet traffic, our GPS satellites, our deep space communications with robotic probes create an expanding electromagnetic signature that grows stronger and more complex with each passing year. But perhaps more significantly, we've begun deliberately advertising not just our existence, but our capabilities. The messages we've sent to potential alien civilizations contain detailed information about our mathematics, our physics, our biology, even our exact location in the galaxy. We've essentially created a cosmic resume highlighting our intellectual achievements and providing precise coordinates for anyone who might wish to visit. If the dark forest hypothesis contains even a grain of truth, these actions might represent the most catastrophic error in human history. Every additional signal we broadcast, every new piece of information we share about our technological capabilities, could be bringing us closer to attracting the attention of civilizations that view our very existence as an intolerable threat. The timeline becomes particularly unsettling when you consider the practical mechanics of interstellar retaliation. A civilization that detected our earliest radio broadcasts in the 1920s and immediately launched a relativistic weapon traveling at 10% of light speed would see that weapon arrive at Earth sometime in the next few centuries. We could be living in the final peaceful decades of human civilization without even knowing it. Dr. Liu Cixin himself has expressed concern about this possibility in interviews following the international success of his novels. He's noted that while the dark forest concept emerged from his imagination, the underlying logic is disturbingly sound when applied to the realities of cosmic communication and interstellar conflict. The author has pointed out that we've already committed ourselves to a particular path in this cosmic game. We cannot unbroadcast the signals we've already sent, cannot recall the information we've shared about our location and capabilities. If predator civilizations exist within our radio horizon, they already know about us, and our fate may already be sealed. This inevitability creates a profound psychological burden for anyone who takes the dark forest hypothesis seriously. How do you plan for the future when that future might be cut short by forces completely beyond your control? How do you maintain hope for human progress when every advance in our capabilities might be bringing us closer to automatic elimination by cosmic predators? Some researchers have proposed that we should immediately cease all attempts to contact extraterrestrial intelligence and instead focus our efforts on developing technologies for concealment and defense. They argue that our priority should be learning to hide our technological signatures, while simultaneously building capabilities that might allow us to survive an attack from advanced alien civilizations. Others contend that such defensive measures would be futile against civilizations advanced enough to threaten us across interstellar distances. If aliens possess the technology to detect our presence from dozens of light years away and launch weapons capable of destroying entire planets, then our best defensive technologies would be like stone spears against nuclear weapons. This technological asymmetry represents one of the most disturbing aspects of the dark forest scenario. Any civilization capable of threatening us across interstellar distances would necessarily be far more advanced than human technology. The same capabilities that enable interstellar warfare automatically create overwhelming advantages in any direct confrontation. The physics alone are daunting. A relativistic projectile traveling at a significant fraction of light speed would carry kinetic energy equivalent to nuclear weapons, while being virtually impossible to detect until moments before impact. Even more exotic possibilities like self-replicating robotic swarms or weapons that manipulate stellar processes could eliminate entire solar systems with technologies we can barely conceive. Against such capabilities, traditional concepts of military defense become meaningless. You cannot build bunkers against weapons that can crack planets, cannot develop radar systems fast enough to track relativistic projectiles, cannot negotiate with artificial intelligence systems programmed for systematic elimination of potential threats. This asymmetry extends beyond mere technological capability into the realm of strategic thinking itself. A civilization that has survived long enough to develop interstellar warfare capabilities would have had millions or billions of years to refine their strategic doctrines. They would have encountered and eliminated countless other species, learning from each interaction and continuously improving their methods. Human military thinking evolved over mere thousands of years of warfare between technologically similar opponents, would be hopelessly outclassed by strategic intelligence that has been perfecting the art of cosmic conflict across geological timescales. We would be children playing war games against beings who have been studying and practicing interstellar combat since before our planet formed. Yet the absence of any obvious attack against Earth provides some evidence that challenges the Dark Forest model's assumptions. If predator civilizations are actively monitoring the galaxy for emerging threats, and if our radio signatures have been detectable for nearly a century, then the lack of any response suggests either that such civilizations don't exist in our cosmic neighborhood, or that their behavior doesn't match Dark Forest predictions. This evidence of absence becomes particularly significant when we consider the exponential growth of our technological signatures over recent decades. Our electromagnetic emissions have grown stronger and more complex. Our space activities have become more visible, and our deliberate attempts at interstellar communication have become more sophisticated. If there's a technological threshold that triggers Dark Forest elimination, we've almost certainly crossed multiple such thresholds in recent years. The development of nuclear weapons, spaceflight, global communications networks, and artificial intelligence all represent capabilities that could potentially be viewed as threatening by paranoid alien civilizations. The fact that we continue to exist might indicate that either the galaxy is safer than Dark Forest theorists assume, or that the timeline for cosmic retaliation operates on scales longer than human civilization has existed. An attack launched in response to our radio signals might still be decades or centuries away from reaching Earth. This uncertainty creates an impossible decision-making environment for human civilization. We must plan for a future that might not exist while preparing for threats we cannot defend against using methods we cannot predict against enemies we cannot identify. Some philosophers have argued that this uncertainty itself represents a form of cosmic torture, forcing intelligent species to live with existential dread that may or may not be justified by actual threats. The psychological impact of believing you might be under observation by hostile forces you cannot detect or understand could be as devastating to a civilization as actual attack. This psychological warfare aspect of the dark forest scenario suggests that even if predator civilizations never physically attack their targets, the mere possibility of their existence could be sufficient to cripple emerging species with paranoia and despair. Civilizations might destroy themselves through fear and isolation rather than through direct elimination by external forces. As we reach the end of our journey through the cosmic darkness, we're left with more questions than answers, and perhaps that's exactly as it should be. The dark forest hypothesis forces us to confront the possibility that our universe might be far more dangerous than we ever imagined, filled with civilizations so terrified of each other that they've chosen eternal silence over the risk of contact. Whether this chilling vision represents reality or simply reflects our own deepest fears about survival in an uncertain cosmos remains one of the greatest mysteries facing our species. What we do know is this: every signal we broadcast into space, every attempt we make to announce our presence to the galaxy, carries consequences we may never fully understand until it's too late. The stars continue their silent watch, keeping their secrets, while we stand at the crossroads between cosmic communion and cosmic catastrophe. Perhaps the greatest wisdom lies not in solving the mystery of where everybody is, but in carefully considering who we want to be when we finally find out. Until then, the dark forest waits, and we must choose our next steps with the knowledge that in this vast cosmic game, there might be no second chances.